Good evening to everyone. And today we are presenting a working paper on the framework for integrating government MLOps in financial institutions. This is a working paper which has been co-authored by Dr. Joseph and Kozar, who is a member of the IIM Academy of Technology, New York. Along with myself, I am the Director of Strategic AI from California School of Competition Business Solution, Dr. Sonia Agural, who is now in IIM Nagpur, but ex-professor IIM at Kolkata, and Mr. Bhattacharya, who is my co-founder. So, the agendas are AI model lifecycle, AI ladder, transfer AI, government MLOps framework for financial institutions, landscape for AI-based financial institutions, and integration for the future scope, that is MLOps with security. So, let us understand what is the burning fact of today. I have been listening to many models which have been discussed in today's session, and most of the things we are discussing about the models which have been developed in the laboratory, right? So the burning fact is that 83% of the organizations have increased their AI budget. The time required to deploy a model have increased, with 64% organization taking months to deploy, but 53% of the AI and ML models which are in the pre-production phase, and most machine learning models never make it to the production. So this is the realistic problem in the industry scenario. And the solution to this particular problem is basically the governed MLOps. So I would request Anushree to please describe the development of ML models and deploying the ML models at scale. So this is basically the different stages, the development stage and the deployment stage. So Anushree, please.
Thank you, Shobha. So, as we all know, that ML models can be divided into two parts, that is development phase and deployment phase. So, development phase is basically concerned with the data that we have, and along with the training the ML model, selecting the respective ML model and training that model with the data, and then using certain evaluation metrics to see how the model is working. Now the question comes in the deployment phase. So once a model has been selected, all the evaluation metrics are working absolutely fine in a confined scenario. Now when this model are given in deployment or in production phase, we can see that the evaluation metrics start decreasing, right? So there are many conditions that leads to these things. So it requires a continuous monitoring, right? After being when it's given to production, it requires a continuous monitoring, continuous integrations with new data, because when it's given in production, new data comes in and it needs to be monitored and it needs to be maintained. And the personas involved in this deployment phase are basically the MLOps engineer, right? So if I need to just take a deep dive into the entire AI model scenario. So it starts with the inception stage. So what we need to develop, so that is a model creation request. Then comes the development, selecting the requisite ML models, and then model validation, that is the accuracy metrics that we have. Then the model approvals from the agencies or the owners who are actually involved in this production process. Then comes the deployment, and then once it's over, deployment is over, like we need a continuous monitoring. And now, if we see that the metrics are decreasing, that could come due to data drifts or model drift, any kind of scenario. We need to take back the model, and if you see the metrics are decreasing, so we need to take back the model. So that is a model retirement. And the financial institution or any kind of institution who needs to employ this ML model has a financial burden in this state. We have to again take back this ML model, and we have to repeat this step. Okay. So next.
For the next slide, I would request Dr. Kozar sir, if you are available online, if you can please explain the AI ladder with a prescriptive approach.
Yes, hi everyone. So in this slide, we illustrate the AI ladder concept, which is really a pursuit approach to transform business by connecting data and AI. So if you look at this slide, starting left to right, there are four rungs of the ladder: collect, organize, analyze, and infuse. So the collect phase is all about being able to connect to data wherever the data resides, and be able to virtualize it or integrate it, bring it into the platform. And usually that's a task that's done by the data engineer or the data provider. And the techniques and the tools used are data virtualization and the variety of data connectors. Once that's done, the next phase is the organize phase. And the organize is all around profiling data, preparing data, discovering what data exists, and running data quality analysis and data lineage to understand where the data is coming from and how it's being transformed. And then also connecting it to the business by enriching the data with a business glossary. That task is also typically done by that combination of data stewards and data engineers working together to bring in the data, and the tool that's used for that is like Boston Launch Catalog with the refinery. At the end of this phase, what happens is the data becomes available in an enterprise data catalog where other data consumers can start searching for the data and efficiently finding it and adding it to their projects, to their analysis and work with it. That leads to the analyze part of the ladder, and that's really where traditionally people think about training AI models. Typically, when people talk about training AI models, they're referring to the analyze phase. But the key point in this slide here is that your data is essential to your AI models, and the better data leads to better AI models. So once data has been connected to the source, enriched, and cataloged, then the data scientists will be able to search and find relevant assets from the catalog, and then they add it to their project to where they would do these 3 steps. They would build and train AI models, and there are different tools that they would use for that. You can use Auto AI or Auto ML tools where you just feed it the data and you rely on AI building a variety of models and exploring what works best. Or you can use things like Jupyter Notebook, where you can use a rich set of open source libraries to build and train your own AI models. Or you can use something called Guided ML, which is kind of a drag and drop functionality to connect a pipeline of processes to get the data from source to build an AI model. After you've done that development phase, that first the first picture in the slide, which is the build and train AI models. The next one is deploying, and that's basically you select the model you like the best, and you actually optimize it, and then you deploy it either for batch inference or for REST API access. And now next step is you actually monitor and manage, operate the AI model. And this is where you're monitoring the AI model for things like fairness and explainability and quality and drift. Because after you go from develop the AI model and when it's in production, the model effectiveness changes. It changes because for many reasons it drifts. That's the term used for drift. And it could be because of data drift, where the data itself that's being used to infer with the model has changed from what the data that was used for training the model. And the users, the persona that's involved with the stages of ICE are typically the data scientists and the MLOps engineers. And we use tools like Watson Studio or AI, Watson Machine Learning, and Watson OpenScale to do these various tasks. And at the top of this AI ladder, we have the infuse route, which is after you have an AI model, you want to start extracting value from it by infusing it into applications, whether it's business processes or customer-facing applications. So again, the point of this slide is to illustrate the end-to-end AI lifecycle as it maps to the AI ladder and the various rounds of the AI ladder. Key messages are, you have good AI models, you need to start with good data, and you need to have high-quality data used to guide these AI models. You need to go through these different stages, and then at the end, you need to infuse into applications to extract business value. Next slide, please. So this slide here illustrates the MLOps components, and again, on the left side, this shows the traditional AI lifecycle, and it goes around similar to what we showed in the previous slide, collecting the preparing data, building the models, deploying and monitoring the models. And at IIM, we talk about, in addition to MLOps, which is the operationalizing of ML models, we talk about governed MLOps, which is applying governance across the MLOps lifecycle to meet the governance and compliance requirements for the enterprise. And one key point here to make is that when we talk about governance and governed MLOps, there are 3 axes we talk about. We talk about governance of data, governance of the model, and the governance of the process. The governance of data is all about using high quality data where we understand the lineage of the data and which data which has been enriched with a business glossary to connect the actual technical metadata to the business terms that the business cares about. And it's important to apply the governance principles around that data. The model governance is all about making sure that the AI models that are trained are ethical, are explainable, are fair, and are robust. So again, monitoring for drift, for explainability, and for fairness. And process governance is all about automation to drive consistency and efficiency and transparency for AI at scale. What that means is that we need to understand, have well-defined workflows with clear tasks, clear owners to understand who is doing what task and who has approved what task to proceed to the next stage. So it's really, governance MLOps is really applying governance across all these three: data, model, and process to deliver high quality and trustworthy AI. Next slide, please. So this is here a sample MLOps, governance MLOps solution architecture for a scenario where you have data that exists in different locations, possibly like in this case showing some data sets existing in DB2 and IBM Cloud, and other data sets existing in DB2 warehouse on-premises. And then it shows how you use data virtualization to actually connect to the data and provide virtualized views of it without actually moving the data. And then with that virtualized views of data, you can catalog it into an enterprise catalog using also knowledge catalog, where you apply quality analysis and privacy to make sure that you mask data that shouldn't be shared with certain users. And then on the right side shows the studio and the life cycle for training the AI models using either OAI or Jupyter notebooks or a combination, deploying those AI models and then validating, making sure that they meet the requirements in terms of performance requirements. And then after validation is complete, you deploy the models to production, and in production you continually monitor the models for, again, fairness, explainability, and drift. And then this is an iterative loop that you continually iterate through until you get the models to meet performance requirements. And the last arrow shows that you can integrate this with another application. In this case, we select to integrate with the Watson Assistant application. So it's really a virtual assistant that's serving end customers, and that application can personalize the experience based on what the AI model predictions like. In this case, this was actually designed for a customer churn prediction use case. Next slide. So this slide here really is all about data fabric and relation MLOps. So we talked about data governance at part of it, which again it means applying governance rules and policies for the enterprise to all data that the enterprise has. Integration is about connecting data, applying TL rules to get the data in the form you need it. Data science and MLOps is the process of training AI models and operationalizing those by deploying them and then iterating through the process of validating and evaluating it in production. And then governance is about governing the overall complete AI workflow. So that data fabric is all about, it's a new concept, a new paradigm that allows you to make sure that right data with a high quality is being accessible to the enterprise across all its silos without necessarily moving the data or copying it over. Now with this, I hand it back to Suba.
Thank you, sir. So now actually we have to think about like how to integrate for the AI adoptions in the financial institutions. So we know that most of the financial institutions like fintechs and US banks are using a lot of AI solutions for their mission critical processes like fraud detections, like understanding like who are the vulnerable customers they should look forward to. So these are all AI and ML model based. So next slide please. So therefore actually Dr. Koses had already described about the healthy AI models like fairness, performance, explainability, confidence, transparency, privacy, and adversarial robustness. So next slide. So MLOps and trustworthy AI. So basically for the financial institution, the basic things are the data strategy, data collection, data access pipelines and preparations, model building and deployment, model monitoring, performance and tracking. So these are the key factors for any modern day financial institutions. And next slide, you can please. So again, the three things are the trust in data, trust in model, and trust in process. Because we know that we have, for a new age artificial intelligence integrated financial institutions, these three things plays a pivotal role for building the trust within the customer, building the trust with the other agencies like regulatory bodies. So next slide. So as Jose have already described, so I just take you through what are the different solutions which are available for deploying the governance with the model ops at scale. I call it at scale is the IIM knowledge catalog which he has already described. Then we have the pipeline AI fact sheet, Watson OpenScale, and CI/CD command tool interface. So these are basically the various tools which are integrated into a single platform for modernizing and like governed MLOps for any institution. So I am basically describing about the financial institutions, but any organizations who are basically using artificial intelligence for at a scale for a larger scalability, they can go for this particular solution. So the business values for governed MLOps. So as you can see from here that basically it is the CAGR is 41% growth, and as you can see that the optimized value is 11.5%. So basically the value creation is around $5 billion by 2025, where the MLOps industry will going to grow. So this is one of the areas. Basically, India is also focusing more on the responsible AI. If you can see that the last conference in the New Delhi on their Prime Minister also spoken about the responsible AI. Even the Reserve Bank of India is also focusing on responsible AI. So, but that is at a strategic level, that is at a visionary level. But how to implement that? So this is our solution how we can implement. Next slide. So now the thing is that we have already discussed about the governance with the MLOps. Now the next thing is when we talk about the financial institutions, the security comes into play. So that is the next area of research what we are ongoing with Dr. Kozal and my organization is integration of security within the MLOps. So it is basically MLSecOps. So that is one of the area of applied MLOps where most of the focus is on, and this is a very recent research area which is in trend, and so what is basically things, so if you can just move a little bit. So basically the 5 main factors of it is basically the supply chain vulnerability, then you have the model preparedness, you have the governance and the compliances, then you have the trusted AI, and finally is the adversarial machine learning. So these are the 5 pillars of the machine learning with security, with operationalization. So basically this is what we are looking into. Next slide. So to conclude it, AI trustworthiness must have an assurance, security, risk, and safety lawyers with potential services at various levels of financial institutions for a holistic implementation of the trustworthy AI technologies driven, and the institutions like Reserve Bank of India's regulations must include it. So Reserve Bank of India should have a pivotal role in integration of this. And developing an ML and AI model is just the starting point, as Sir has already described. But to bring it to the realistically, to production stage, this is the need what we are basically discussed today and explained to you to integrate the governance, because there are two phases. One is governance and second is the deployment. So until and unless you have high quality of data, highly regulated data, clean data, and trustworthy data, along with the deployment, which is basically across the organizations, the trustworthiness for the AI models cannot be developed. So that is about the conclusion. Next slide, please. So this is our references. So this is a very upcoming topic, and most of the research across the globe is basically focusing on the deployment part with the data governance, and so Deloitte, McKinsey, and everyone, like the most of the major consulting companies are focusing on this. Next, so we are the 4 authors who have written. So most of the architectures are by Dr. Kozal sir. Then we have integrated into the financial domain, and we are trying to create the value creations how the financial institutions can find it valuable. Dr. Sonia Agrawal madam is another author of us, and Anushree has already contributed equally to the development of this project. So thank you very much, and next slide. So we are open to the questions. So sir,
in that case, have you done any case study?
Yes, we are basically doing a case study on.
You are doing?
Yes, we are.
It's not reported here?
It's not reported because like the cases are mostly because we have another slide deck where we have taken up a case study of NatWest Bank. So basically NatWest has implemented it. So Kozal sir, can I get some more time? Yeah. Hello sir, are you there? Hello?
Yes, sorry.
Yes, sir. Miss, can you just explain because Dr. Shwarkar is asking, do you have any like a case study where this have been implemented? So if you can please highlight on that.
Yeah, this government MLOps customers, and basically it has been applied to multiple customers, and I don't know if you're looking for certain results or have results to share you, I can even share customer names. But it is a common methodology that we apply to our customers, and it's all about being able to connect the right data, making sure it's high quality, and then making the right data as catalog, and then using that data, you deliver higher AI models, and the biggest part is also applying the governance on the AI models themselves, not just the data. So yes, we have applied this to multiple customers, but I don't have any specific data to report on that.
Okay, so I guess that it is in process.
Absolutely.
So another point is we were talking about the Watson data fusion, right?
Yes.
So from different areas, different types of data, different variables are coming up. So how is fusing all the different data types?
Sir, can you answer to this question? Sai is asking that different data are coming up from different sources. So how these different sources of data is being infused?
Which is called the, for example, the embedding of the data.
Yes,
For
that is
example, I am
asking.
collecting the image data, I am collecting also the text data, I am collecting the categorical data, audio data. How I am embedding it?
Yeah, actually it is getting dumped in a data lake, right? So it isn't dumped and you have
Data lake is storing the data. Data lake
Yes.
now, whenever you are marching for any analysis, the coherence and other
yes,
consistency
that
part
is
has to be
being
maintained.
catered by the Watson knowledge catalog. So that is how
So this catalog is
as
always
you-
helping.
yeah,
this thing for
actually
the
whenever
consistency.
we actually in catalog we have the thing called metadata. So metadata gives you the information that where the data is being stored, what kind of data it is, and what is the maybe the memory allocated, right?